Thank you for joining. We'll give people a few moments to join the webinar here, and then we'll kick off. I'll just pop myself on mute for a moment. Okay, now we have a few people joining us. I shall kick off. So today we're talking about DevSecOps, specifically as it regards Amazon's EKS and Sumo Logic. So a bit of an agenda for today. We've got the welcome, which is now. Welcome, thank you for attending. We'll talk about what is Kubernetes, a bit of an introduction to Amazon EKS, how that relates to EKS and Sumo Logic, and then we'll have a bit of time for Q&A at the end. With me today, I have James Schaefer from AWS. If you'd like to introduce yourself, James.
Thanks, Eddie. Hi, everybody. I'm James Schaefer, Senior Partner Solutions Architect with AWS. I've been with AWS as a Solutions Architect for almost 3 years now and work with a number of partners and customers in the enterprise space. Thanks, Eddie.
Thanks, James. By way of introduction for myself, my name is Eddie Thompson, and I am Lead Solution Engineer for Sumo Logic here in the APJ region. I've been here for a bit over 4 years now, so it's been very interesting to see us sort of grow from pretty logging specific stuff to a full observability platform, and yeah, really enjoy working with our customers in region on solving their observability challenges that they have today. So I shall shuffle along and hand over to James for this first bit about what is Kubernetes.
Fantastic. Thank you very much. Before we dive deep into the Sumo Logic and AWS technology solution, I'd like to talk about Kubernetes at a high level. Kubernetes is an open source software that allows you to deploy and manage containerized applications. Importantly, it allows you to do this at any scale, from small developer-centric environments through to large enterprise production scale. You can use it to run your containerized applications anywhere without needing to change your operational tooling, whether this is on-premise, in the cloud, or a hybrid environment. At a high level, Kubernetes works by managing a cluster of compute instances and scheduling containers to run on that cluster. Containers are run in logical groupings called pods, and you can run and scale one or many containers together as a pod. The Kubernetes scheduler is the process that assigns pods to nodes, and nodes are the worker compute instances within the cluster. In a typical Kubernetes implementation, we'd see Kubernetes control plane determine the when and the where to run your pods. It manages traffic routing and scales your pods based on utilization or any other metrics that you define. Kubernetes automatically starts pods on your cluster based on their resource requirements and automatically restarts pods if they or the instance they are running on fail. We find that Kubernetes is popular with developers because it allows them to take advantage of a broad set of ecosystem tools. It integrates drivers for configuring network, storage for your application. It also has a consistent set of open source APIs for broad flexibility. Next slide, please. There are a large number of benefits of running Kubernetes, from simplified and consistent deployments through environments, through to a huge flexibility in where you can place your workloads. However, we've heard from our customers that managing Kubernetes at scale is hard. Running clusters at production scale is complicated and requires trained people who spend a significant portion of their time managing environments. In addition to this, operations teams need to ensure that their workloads are deployed in a secure manner, without exposure to known security vulnerabilities. And this further increases the operational overhead of running Kubernetes on your own. The operational heavy lifting doesn't directly drive the organization towards its business objectives. So by reducing the undifferentiated heavy lift, our customers are able to have their skilled team members turn their attention to developing products or offers for their customers. And this is why a lot of our customers come to rely on Amazon to handle that undifferentiated heavy lifting of securing and operating Kubernetes at scale. Next slide, please. The platform you're running Kubernetes on impacts the quality and speed with which you can bring new product and offers to your customers. Your customers likely have expectations around performance, availability, and security of your product, how quickly new features are introduced. If your app is down when they need it most, it has a lasting impression on your customer base. With that in mind, AWS global infrastructure is built for performance. AWS regions offer low latency, low packet loss, and high overall network quality. This enables teams to design applications to meet those tough SLAs. Further to this, AWS is architected to be the most flexible and secure cloud computing environment available today. Our core infrastructure is built to satisfy the security requirements for the military, global banks, and other high-sensitive organizations. Couple this with more than 200 fully featured services, and you can understand why. Next slide, please. We see the vast majority of customers running containers in the cloud run them on AWS, and this is around 2/3. So to bring this together, I'd like to focus on Amazon Elastic Kubernetes Service, EKS. It's a managed Kubernetes service to run Kubernetes in the AWS cloud and on-premise data centers. But in the cloud, Amazon EKS automatically manages the availability and scalability of Kubernetes control plane nodes responsible for scheduling containers, managing application availability, storing cluster data, and other key tasks. With Amazon EKS, you can take advantage of performance, scale, reliability, and availability of AWS infrastructure, as well as the integrations with AWS networking and security services. As per our earlier slide, our customers choose EKS because it allows them to focus on their business applications and offload the undifferentiated heavy lifting. Specifically, the tactical operations associated with self-managing infrastructure for application deployments that add no direct business value. EKS provisions and scales a Kubernetes control plane, including the API servers and backend persistence layer, across multiple AWS availability zones for high availability and fault tolerance. It automatically detects and replaces unhealthy control plane nodes and provides patching for the control plane. Amazon EKS performs managed in-place cluster upgrades for both Kubernetes as well as the updates to Amazon EKS configuration and security patches. EKS integrates with many AWS services to provide scalability and security for your applications. These services include Elastic Load Balancing for load distribution, IAM for authentication, Amazon VPC for isolation, and AWS CloudTrail for logging. And with that, I'll pass back to you. Thanks, Eddie.
Thank you very much. So, a little bit about how Sumo can help with Kubernetes and EKS specifically. So, we like to be able to say that you can streamline with unified observability. And if any of you have seen or worked with Sumo's Kubernetes collection before, you may notice a couple of differences. Specifically, here, and here, regarding OpenTelemetry. So we're up to our version 3 branch of our Kubernetes collection, and we're gradually working towards our unified OpenTelemetry based collection. So now we have deprecated FluentBit and FluentD from our environment and are using OpenTelemetry for collection of logging, for collection of events from the Kubernetes API server, and for our enrichment pipeline, which tags all of the data with service, deployment, and namespace, in addition to things like node, pod, and container. We're still using Prometheus for metrics collection, And OpenTelemetry is there from the start for distributed tracing, and also the option of installing Falco for some kernel level security information too. So yeah, some interesting updates there. So we'll talk a little bit about DevSecOps and what we can do around securing Kubernetes. So as we've heard today, it's a container orchestration system. It's open source, and importantly, it's a CNCF certified project. So that's the Cloud Native Computing Foundation. So they're the organization which governs the project, and they're part of the Linux Foundation. Importantly, resources are ephemeral, and that is by design. So they are temporary. They're created and destroyed as needed. And that means your monitoring and your observability needs to be aware and take that into account. So it guides and controls your containers just like a ship's helmsman. And if you haven't seen it before, then yeah, K8S is a common way to represent the word Kubernetes, and it replaces the 8 letters in the middle with a single numeral. So where does Kubernetes need some help? Because Kubernetes handles infrastructure and not analysis, you need to have some third-party tools that you can leverage to get insights into potential breaches, investigate past events, and audit and interpret any logs and metrics for security purposes as well. Now, Kubernetes does pose some unique security challenges. Hot and network policies are provided, but not necessarily enabled. This can be okay for testing, but not necessarily for deployment. May not be customized to your specific team's needs, and you need to do some configuration to help protect and encrypt your network here. Having a strong support such as AWS is a really important part of getting that security right. So host security is important as well. And you can also do things like enable SE Linux or AppArmor on your actual EC2 hosts as well. But one of those important things to remember is abuse of the, or potential abuse of the Kubernetes API. So beyond following any standard RBAC and security policy settings that you define, Kubernetes does not look to detect or respond to API abuse. So you can use the Amazon EKS to monitor the API activity, and you can use Sumo to audit that, that trail as well. So we can pull in that audit data from CloudTrail in addition and monitor that in Sumo. Importantly, we have auto discovery with our Kubernetes solution. So as I mentioned before, everything in Kubernetes is ephemeral. So you can scale things up and down, pods can come and go, nodes can be added to the cluster. And if you needed to add all of those things manually, it'd be a bit of a nightmare. So yeah, importantly, we do auto discover things to make it nice and easy for you to discover these in your environment. And importantly, we do have security as part of that solution, both on the side of Falco, which is a kernel level anomaly detection tool that was open sourced by Sysdig, and provides the useful out-of-the-box set of rules, but importantly, also provides you the ability to add in your own sets of rules or others which have been written and published by other people in the open source community. You can sort through these and see which rules have been triggered by things like particular users, which parent process, which namespace or pod they occurred in. And for true DevSecOps visibility, make sure you're using our Amazon EKS app. So that provides you visibility and operational insights into the EKS control plane. So although Amazon are responsible for running that service for you and managing its scaling and reliability, this provides you with dashboards to audit what's going on with API server access and audit what's going on with the controller manager, the authenticator, and the scheduler. So it allows you to dive into that that data and see it alongside your sort of infrastructure and operational metrics. Now, Sumo Logic for Kubernetes on your own machine. So we have a training environment which we're going to use shortly. And Kubernetes is already installed in the training lab environment and has some data flowing in. If you wish to install Kubernetes in your own environment and send some data through to your own Sumo Logic account, you can check out the Kubernetes Helm installation self-paced course. Or if you're already a bit of a dab hand with Helm, just have a look for Sumo Kubernetes collection GitHub, and you will find our deployment guide. I might actually get Suresh to look that up and drop a link into the chat as well. But let's get on to the labs. So I've been talking for a while now, so let's do something a bit more fun, and you can join in as well. So to start with, we need to log into the training environment. The URL for that is service.sumologic.com. The email you will use to log in is training plus analyst, and then 3 digits between 001 and 999. So you can add that in, training plus analyst, for example, 123 at sumologic.com, and the password is March with a capital M 23 Sumo with a capital S exclamation mark. I might get Suresh to drop those into the chat as well. When you have logged in, we can proceed. If anyone has any difficulties logging in, please ask a question in the Q&A or drop a question into the chat. So I shall log in. Well, apparently I have already logged in. So the lab one is to install the Amazon EKS app. So we're going to have a look in a folder for an EKS app, search for EKS, and install the app using the source of labs/Kubernetes v2 EKS. So to get to the app catalog, I go click on the left. I'm going to search for EKS, or I could click down here to Kubernetes first and click on EKS. I'm going to click into Add Integration. And Suresh, you just want to drop the password into the chat, please, as well. So it was March 23 Sumo exclamation mark.
I will do that now, Eddie.
Thank you. So back to the lab. So we're going to search for EKS and install the app using the source labs/Kubernetes v2/EKS. So I've got my app catalog here, my folder name, call this AWS at the end. And we've got labs/Kubernetes v2/EKS, my source category. It's checking that Sumo can receive the data, and it's letting me know some dashboards that I can open. So let's have a look. There we go. So I can see some successful versus failure request rates. Where's my severity breakdown? And where are my recent error logs? So we can view the pre-built dashboard. So I'm going to open up the Amazon EKS folder under my personal folder and have a look at the API server audit dashboard. So let's go over here to the library and my personal folder. And I can see here where I've installed it. So I put any AWS at the end of it. And the dashboard it was looking at was EKS API server audit. So I can see where's my non-200 counts, my failure rate, my status code trends. I'm only looking at the last 15 minutes here. So if I drop it back to an hour, I might see a little bit more information here in my trending data. What are my top failure reasons? Conflicts not found. Top users by failures. Top URLs with problem status codes. URLs with non-200 responses. Who are my most active users? Failure reasons and namespaces. Requests by stage. So oddly enough, I'm getting more responses complete than responses started. And requests by audit policy. So navigate to Kubernetes to the security dashboard. So we're going to get to the dashboard from a slightly different view this time. So I'm going to go back and close the dashboard I've got open. I'm going to click on the new button and go down to explore. So this is how I can look through some various Kubernetes clusters, which I have running in my training environment. And they have different namespaces, different amounts of nodes and pods running on them. Now, the lab here is asking us to navigate to a security dashboard. So we're going to select first the Kubernetes node view, and then we're going to look for the security overview. So at the moment, I'm looking at the namespace view. I'm going to drop down to the node view. Now, this is looking at the same data. It's just providing it in a different ordered lens. So rather than ordering it by namespace here, we can see the compute nodes that it is running on. and the dashboard that's related, I can see going down to security overview. And so this is letting me know what is happening in the Falco environment on this particular cluster. So I can see here, what are the timeline of my events, how many total events, how many emergency alerts, how many errors, which rules have been triggering the most frequently, which rules have been triggered by user, by process, and by priority. So this is giving me an overview of the environment, and it may depend on which cluster I have running as to the different set of information that I get. But this is an overview dashboard. I can always drill into the underlying errors in the logs to see the messages coming from Falco. You don't actually have a lab guide, so don't worry too much about that. So hopefully that's given you a little bit of an insight into how we can use Sumo Logic to investigate more of what's going on with our environment in Kubernetes. So as we just saw here, we can actually use this explore view to get to related dashboards. So the same dashboard that I installed before for the API server audit, where was that? I can load up here within my explore view, as well as going directly to the dashboard itself. So these can be made contextual to the particular views that you have. So we're at the end now. So any questions that anyone has, please feel free to drop them into the Q&A and I shall do my best to answer them. Or if it's something about specific to AWS, I shall hand it over to James. No, if no one else has any questions, then I will thank you very much for taking the time to join us today. Been really great to talk to you a bit about what we can do with AWS and Sumo, and I thank you very much for attending.